So I'm going to focus on some actual real numbers and data, picking up a little bit on what Marcus talked about in terms of demand, and then talk about the network performance here in Europe. Some of you know that we do a series of studies every year called our Visual Networking Index study, and part of that we also do a study on cloud readiness, and I've taken data and put those together. I will look at the type of network that's needed to support cloud services, and then take a look at the capabilities and network performance on both fixed and mobile for Europe. Methodologically, we're always asked, how do we do this? And as you can see, we have about 45 million speed tests from 150 countries as part of the study. Some of you have seen some of this. I'll go through the first part very quickly. What we are seeing in terms of our latest global mobile data, which was the study that was released at the end of February, we're seeing globally a 66% compounded annual increase in the growth of data across mobile networks. And in Western Europe, and I have Central Eastern Europe and then combined, but for the sake of time, I will just focus on Western Europe. We're looking at, because it's a more mature market than the global average, we expect it to grow 8 times over the next 5 years, from 2012 to 2014. We're always asked, well, where did the numbers come from? Do you just make them up? No, actually, we actually go back and check. A lot of people who do studies don't go back and check. This is a rolling 5-year forecast. We are in year 7, so we actually can go back and see what we projected and see how we did. And the short answer is the numbers are actually quite reliable, and they are within a range. In fact, you can see that actually the forecasts were slightly below the actual. A couple of points with real data to reinforce some of the points that people made earlier. We've seen a dramatic shift and continuing to see a dramatic shift globally, but especially in Europe, from laptops and non-smartphones, right, GSM phones, to smartphones. And also we're seeing, in terms of devices, significant shift to, just in terms of devices, not heavy bandwidth, machine to machine. And you can see here in Europe, Western Europe, the dramatic decline in GSM. These are devices. In terms of connections, the dramatic decline of GSM phones, the growth of 3G, and the beginning of the 4G take-up. But what is most interesting to me is that when you look at the data generated by the different devices, even though you still will have 12% of the devices connected to GSM, for data, forget it. It's irrelevant. And although you're looking at a relatively small percentage of 4G devices, that's going to be almost half of the data. What we see, and we see this globally, is that the data applications that are driving this dramatic growth in demand are video and cloud. We're forecasting for Europe 85% of the data that people will be using on their smart wireless device will be cloud-based. So then the question is, what do we mean by cloud services? A lot of people talk about cloud, but they never actually define it. So what we've done is we've gone back and we've looked at different types of cloud applications and the type of network performance needed to support those types of cloud applications. And what we did was we created 3 very simple, maybe oversimplified baskets of cloud services, basic, intermediate, and advanced. And these are for an individual cloud application. And you'll see in a moment, most of the uses of cloud, especially for advanced cloud, are not single applications, but multiple concurrent. So if you look at the basic cloud app, the requirement's not that great. It's only about 750 kilobits down, 250 up. Turns out, actually, when we first did these data, for me, always there's something that surprises me. I thought the requirement to meet cloud applications was a bandwidth requirement. Turns out that's not the barrier. It's not the gating factor. It's latency. So what we see for basic, these are examples of what fits within each one of these. Latency is not that big a deal. But when we get to intermediate cloud, which is going to require probably a megabit to 2.5 megabits down, up to a megabit upstream, latency of less than 160 milliseconds. And when we move to advanced cloud applications, it's more than 2.5 meg down. It could be as much as 3, 5, 8 down for each one. And a megabit, more than a megabit up, and latency of less than 100 milliseconds. Now, as you'll see, the good news in Europe is that on average, most of the European fixed networks can support intermediate or advanced cloud. Single applications, not necessarily full concurrent. But it's mobile where we're having the difficulties. So an example of some of the advanced cloud applications are the kinds of productivity enhancing applications in industrial design, laboratory work, biomedical, education, healthcare that we see in industry and business and education and public services where people are in different locations sharing data, working together, creating new things. And in order to do that, when we begin to look at a typical application, you realize that a typical application in that environment, and I'm not just talking about somebody at home playing games, I'm talking about the economic enhancing applications that require intermediate and advanced cloud access. The network and network performance becomes critical. Let me give you a very concrete example. Right? We see that all of the construction, right, a new building that's going up. Right? Typically what happens is you'll have the architect draws the designs, you have the construction crews put it together. Before they're going to pour the concrete, right, all the conduit is put into the floors. There'll be a supervisor. And what they do is they check. They have the blueprint, and they take a look at the conduit. Is it going in? Is it the right place? They have to make sure before they pour concrete. Once you pour the concrete, if you have to, make a change, it's really hard. Problem. What you can now do with these applications is, let me give you a scenario. So the building supervisor is there. The conduit is done. They're pouring concrete tomorrow. He's out there with the blueprint. He pulls the blueprint up on his tablet and matches it to the conduit that's laid out, and there's a problem. It doesn't match. And maybe the architect is sitting in the home office in Frankfurt, calls him up in real time. They work through together, right, with a real-time video from the tablet, the smartphone. They're sharing the data off of the computer at home, at the home office, pulling up the application and making changes in the blueprint to see whether they have to rip up some of the conduit and change it and delay pouring concrete, or whether they can make it work. Right? Very simple. And by the way, something like that with checking could take days or weeks and delay a construction project. That can be done in real time. What I just described was probably 2 or 3 intermediate and at least 2 advanced cloud applications. In order to do that, it's going to require probably 15 to 20 megabits down, at least 5 to 8 megabits up, and latency of less than 100 milliseconds. Very simple. And by the way, most of the conversation about broadband misses the point. It talks about broadband as a single dimension, download speed. Broadband is multidimensional. Download, upload, latency, and jitter, the 3 critical dimensions: download, upload, and latency. So let's see how the networks in Europe, some of the networks in Europe, and I have data on every country in the 27 countries, member states, but I've just used some for examples. What we can see in terms of fixed networks, this is average upload, average download. And you can see some countries, not surprising, do quite well. Korea, Hong Kong, Japan, right? But some comparisons. Here is the EU 27 average. Here is Western Europe average. Here is Central Eastern European average. Well, let's just take a look now at the European countries and where they go. Interestingly, Lithuania is among the best on the fixed network. Why? Because of fiber and fiber deployment. We had the conversation in the previous panel about VDSL with vectoring. Great near-term technology, but it is not future-proof. So maybe it allows us to do a more stepwise investment. At the end of the day, the rest of Europe is going to have to look like Lithuania. That's fiber. So let's take a look at some specifics. So here, just looking at the European countries, the EU average is pretty good on average. Averages, of course, have their own problem. It's 13 megabytes down, 5 up, and latency of less than 53 milliseconds. No problem supporting multiple advanced cloud applications. Western Europe, 12.5 down, 4 up, same thing. Central Eastern Europe. But now let's take a look at some countries. That's the specifics for Lithuania. On average, 27 megabits down, 21 megabits up in 39 milliseconds. That is what you see there is fiber versus copper in that average because of the narrowing of the upstream and downstream and a much more symmetric network. In Greece, well, we can do an intermediate cloud application, maybe one advanced. This is a reflection of heavy emphasis and reliance on ADSL. It's not even VDSL. Latency is good. Germany, 13.5 down, 2.5 up. So this is good. We could do at least 2 advanced cloud apps on average in Germany. Italy, because I know Luigi is here, very similar to Greece. Big asymmetry because of the reliance on ADSL. Now, moving to a VDSL architecture helps eliminate some of that symmetry gap. But at the moment, on average, we really can't do an advanced cloud app. For our friend from Kenya, because you're here, I've added, I know you're not one of the 27 member states. Here's Kenya's, on average, on the fixed network. Look at this. In terms of download, upload, actually pretty good. The problem is latency on the network, which means you can't do an advanced cloud application, maybe an intermediate. So there's some latency issues in Kenya. These are really, in my mind, diagnostics to begin to look at and unpack. Now, let's look at mobile networks. By the way, I use the term mobile network incorrectly. There is no such thing. I have no idea what a mobile network means. I don't know of any network except maybe some satellites that actually move. Right? I'm mobile. The network is fixed. The network doesn't move. The first thing that happens from my handset, my smartphone, my tablet, it goes to the base station, and what happens? It goes into a fixed network, either microwave backhaul or fiber or an E1 on copper. So, Europe does pretty well. We don't have the data for all 27 member states on the mobile because of the, we didn't have enough data to make it reliable. So I have some countries, not every country. But in terms of comparing to the world on the mobile, the EU 27 do pretty well. All right, let's just look at some of the specifics. By the way, in terms of supporting, because of latency, supporting advanced cloud app, and it's really one, Hungary is the only member state that can support advanced cloud on mobile. As an average, Central Eastern Europe cannot. Western Europe can. That's Ireland. It's difficult to see with the dark. So the average is 3 down, 1 up, 130 milliseconds, intermediate cloud. No advanced. Western Europe average, same thing. CEE, same thing.